Venus is often referred to as Earth's twin due to its similar size and mass. But beneath this resemblance lies a world of stark contrasts. The planet's surface is shrouded in thick clouds of toxic sulfuric acid, and temperatures soar above 460 degrees Celsius, hot enough to melt lead. Its atmospheric pressure is more than 90 times that of Earth, creating an environment that is crushing and inhospitable. These extreme conditions present significant challenges for any attempt to make Venus habitable. Scientists and engineers must grapple with the planet's relentless heat, corrosive atmosphere, and intense pressure, making the idea of transforming Venus into a livable world one of the most daunting tasks in planetary science. In the early days of space exploration, Venus was a prime target for scientific inquiry. The Soviet Union led the way with its ambitious Venera program, successfully landing several probes on the planet's surface between the 1960s and 1980s. These Venera landers transmitted the first images and direct measurements from Venus, revealing a world shrouded in thick clouds and extreme atmospheric pressure. Initial data suggested that Venus might once have had conditions suitable for liquid water, sparking curiosity about its past. However, the probes also detected scorching surface temperatures and a dense, carbon dioxide-rich atmosphere, challenging earlier hopes. The findings from the Venera missions fundamentally changed our understanding of Venus, highlighting its harsh environment and prompting new questions about planetary evolution. Floating cloud cities in Venus's upper atmosphere present a fascinating vision for future human habitation. Unlike the planet's hostile surface, the upper layers offer temperatures and pressures remarkably similar to those found on Earth. Here, vast platforms could be suspended above the clouds, shielded from the corrosive effects of Venusian gases. Scientists propose that these habitats could harness solar energy and extract water from atmospheric compounds. The idea is not purely science fiction. It is grounded in real engineering challenges and possibilities. By leveraging the unique conditions of Venus's atmosphere, humanity could one day establish thriving communities far above the planet's inhospitable ground. Cloud colonies on Venus present a compelling vision for humanity's first outposts beyond Earth. Suspended high above the planet's hostile surface, these floating habitats could tap into the surrounding atmosphere for essential resources. Advanced extraction techniques would allow colonists to harvest water vapor and trace elements, while innovative chemical processes could neutralize the corrosive sulfuric acid found in Venusian clouds. Harnessing abundant solar energy, these colonies could power life support systems and drive further technological development. Over time, such capabilities might enable large-scale geoengineering projects, gradually transforming the environment to support more sustainable human habitation. The success of these cloud colonies would mark a significant milestone in our ability to adapt and thrive in extreme extraterrestrial conditions. Scientists have proposed an ambitious plan to cool Venus by deploying a massive sunshade in space, positioned to block a significant portion of sunlight from reaching the planet. By reducing the amount of solar energy absorbed, the surface temperature of Venus would gradually decrease over time. The physics behind this concept relies on the sunshade casting a shadow, effectively lowering the planet's energy input and slowing the runaway greenhouse effect. As the temperature drops, the thick, toxic atmosphere, primarily composed of carbon dioxide, would begin to change. Over decades or even centuries, cooler conditions could allow some atmospheric gases to condense or precipitate, potentially making Venus more hospitable. This transformation would be a slow process, requiring careful monitoring and adjustments to the sunshade's position and size. The project represents a bold step in planetary engineering, aiming to reshape an entire world through the precise control of sunlight. Several innovative strategies have been proposed to address Venus's dense carbon dioxide atmosphere. One approach involves importing hydrogen, which could react with atmospheric CO2 to produce water and graphite. effectively reducing greenhouse gases. Another method is electrochemical carbon capture, where electricity is used to separate and remove carbon dioxide from the atmosphere. Additionally, carbonation techniques aim to lock CO2 into stable rock formations by encouraging chemical reactions between atmospheric gases and surface minerals. Each of these methods presents unique technical challenges, but collectively, they offer promising pathways for transforming Venus's environment. The ultimate goal is to create conditions more suitable for future exploration or even habitation. Restoring water to Venus is a formidable challenge, but several innovative methods have been proposed. One approach involves redirecting icy comets from the outer solar system to collide with Venus, delivering vast amounts of water to its surface. Another possibility is manufacturing water on-site by combining hydrogen, sourced from space or chemical reactions, with oxygen extracted from Venus's atmosphere. As water accumulates, it could eventually form oceans, dramatically transforming the planet's landscape. The presence of large bodies of water would enable the development of a hydrological cycle, with evaporation, condensation, and precipitation shaping Venus's climate. This cycle would help regulate temperatures and potentially support future ecosystems. Achieving these changes would mark a profound shift in Venus's environment, bringing it closer to conditions found on Earth. Thinning Venus's dense atmosphere is a monumental step in its transformation. As carbon dioxide levels decrease, the planet's oppressive clouds begin to clear, unveiling a landscape bathed in sunlight. Blue seas gradually emerge, reflecting the open skies above, a stark contrast to Venus's former shroud of toxic haze. The surface temperature drops, making the environment more hospitable. However, despite these dramatic changes, the air remains devoid of oxygen, rendering it unbreathable for humans and most terrestrial life. The world is visually transformed, yet still inhospitable, awaiting further steps to make it truly livable. In the final stage of terraforming Venus, scientists begin the delicate process of introducing life. The first organisms to arrive are hardy microbes, specially engineered to survive in the planet's transformed environment. These microbes play a crucial role in breaking down toxic compounds and initiating the production of oxygen. As conditions improve, more complex forms of life, such as algae and plants, are gradually introduced. These organisms further enrich the atmosphere, steadily increasing oxygen levels and paving the way for a balanced ecosystem. Over time, the combined efforts of countless species reshape Venus, transforming it into a world capable of sustaining life. Terraforming Venus presents extraordinary challenges, with costs that extend far beyond financial investment. The risks involved are immense, ranging from unforeseen environmental consequences to the potential loss of unique planetary features. Once initiated, many of these changes would be irreversible, fundamentally altering Venus in ways that cannot be undone. This reality underscores the importance of proceeding with caution, ensuring that every step is informed by rigorous scientific understanding and ethical consideration. Learning from past experiences and thoroughly evaluating each decision is crucial to avoid unintended outcomes. Ultimately, the transformation of an entire planet demands a level of responsibility and foresight that humanity has rarely been required to exercise. Venus presents a unique opportunity for humanity's expansion beyond Earth. By establishing floating colonies within the planet's temperate upper atmosphere, we can bypass the inhospitable surface conditions while harnessing abundant solar energy. These airborne habitats could serve as hubs for scientific research, resource extraction, and advanced manufacturing, effectively transforming Venus into a factory world. The challenges of operating in such an environment would drive innovation in materials science, robotics, and life support systems. As we refine these technologies, Venus could become a proving ground for large-scale planetary engineering, providing valuable insights for future missions to even more distant worlds. This approach positions Venus not only as a destination, but as a stepping stone in humanity's journey to mastering the solar system. Imagine Venus, once a scorching and inhospitable world, transformed into a planet teeming with oceans and vibrant life. This visionary future reflects the boundless potential of human ingenuity and determination. Through advanced technology and unwavering resilience, humanity has reshaped an entire planet, turning adversity into opportunity. The rebirth of Venus stands as a powerful symbol of our capacity to adapt, innovate, and breathe new life into even the harshest environments. It serves as a testament to the transformative spirit that drives us to explore, restore, and thrive beyond the boundaries of our own world. As we reflect on the journey toward making Venus habitable, it becomes clear that imagination, patience, and courage are essential qualities. Imagination fuels our ability to envision solutions to seemingly insurmountable challenges. Patience reminds us that progress in planetary science unfolds over decades, sometimes centuries. Courage drives us to take bold steps into the unknown, undeterred by setbacks or uncertainty. Together, these traits form the foundation of every great scientific endeavor. While the path to transforming Venus may be long and complex, it is filled with hope and possibility. The dream of a habitable Venus inspires us to push the boundaries of what is possible, reminding us that even the most ambitious goals can one day become reality.